Welcome to another episode of Flying High with Flutter. I'm your host, Alan Wyma, and you can see my lighting's a little bit not that good because I was rushing to come to the show. We have a great guest on here. We have Denis Magda.
Hello, everyone.
As you
Hello,
can see,
everyone.
I didn't even prepare your slide for you, so let me go ahead and fix that while you're going on there. Maybe while I'm fixing that, do you mind to kind of give a quick introduction about yourself?
Yeah, so the reason why you folks going to hear me on this podcast, we will be discussing a book called Just Use Postgres, which was published, I think, when a couple of months ago. I'm the author of this book, and during my day-to-day job and activity, you can think about me as a software engineer who is focused on the system engineering, platform engineering. So I work a lot with databases. I work with the backends as well as front ends. So my goal is to understand the entire stack, uh, which will let us build reliable and fast applications. And when you need to build reliable and fast applications, you need to know pretty much all of the components from the top to the bottom. So that's just my quick intro.
So I actually had the most amount of time to actually prepare for your episode, and I did a lot of research. And you've been doing quite a few podcasts about this book, and I thought it was pretty interesting to actually listen to your background. So your background is that you were, I guess I could, faithfully say you were pretty much a very heavy Java person. So heavy that you were in the internals of the JVM and also the JDK. Is that right?
Yeah, my first 5+ years, if not more, probably even 10 years, at the very beginning of my career, I worked with Java a lot, and I worked for Sun Microsystems, for Oracle, not just using Java, but also building Java virtual machine, Java development kit, GDK. That was not for the standard edition, which you usually run on servers and desktops, but that was the Java for the mobile phones and for the embedded devices. So first I was building GVM for, like, there was the GVM called Java EME Mobile Edition, and it was quite popular. Some of the folks out there can remember it. It was widespread until Google released Android, which is also a Java-based GVM, but it was developed by Google. And after that, my focus switched to the embedded devices. I was on the team. I was leading the team that whose goal was to take GVM and GDK and to make sure that it works on different microcontrollers, different low-level systems. And that was a fun exercise because you were kind of enabling GVM and GDK for, let's say, for some circuit board, and but most of the time you have to code in C or C++. So this is how it looked like from inside. But yeah. After learning Java and after working with Java a lot, I stay connected to the Java community. But I decided to broaden my understanding of the technology, and I switched to the world of databases. And then I spent probably the rest 5 or 7 or 8 years, I don't even count, working with different databases. And Postgres is one of them, and Postgres is my default database. And eventually I decided to share my experience and wrote the book that we are going to discuss today a little bit.
The book is something that's quite interesting. When I first heard the title, I was thinking like, okay, this is going to be a very heavy, strong, like, okay, drop whatever database you're using, use Postgres. But that's actually not the style that you wanted to go for. You want to go for more of like, if you're already using Postgres or you are open to change or you don't know what to use, Postgres is definitely something that you should take a look at. Not just take a look at as a relational database, but as like a just an all around like kind of like I guess I can call it like a Swiss Army knife of tools, right? Because it has so much stuff in it. Like it's insane all the stuff it has in it. I was just looking this morning how I can better use the formatting of currencies because I want to be able to from the database format a currency, but it sadly it doesn't work the way I want it to. I want to be able to pass in a currency symbol and get it out because my application, I have like Hong Kong dollar, US dollar, Chinese RMB, euro. I have all these currencies I have to deal with. But yeah, that's kind of besides the point. But like something that you touched on in, I think you're going to touch on in the book. I haven't gotten that far yet, but I think you definitely went over in a podcast, another podcast, is PubSub. I was actually invited to be on another podcast because I actually used Postgres PubSub on a database trigger, and like all these people, like I presented it again like several years later at a local dev meetup, and all these like developers like were like so excited. They're like, "What? You can do that? I didn't know that Postgres has a PubSub. I always reach for Redis or some other kind of tool." Is there something in particular about Postgres that you think is like so surprising, like a feature like this, or you just kind of like this is of course this is very normal because you've been using Postgres for, I mean, I don't know how long. I'm afraid to ask how many years now because it's been a while, no?
Yes, Postgres, if to talk about the title, why this title first, and then we can talk about PubSub and the other capabilities. The title is not my invention, just use Postgres, but obviously it draws attention. Even if you don't use Postgres, you will not, just pass by this book if it's titled Just Use Postgres, because it sounds provocative. And many, like when you read such a title, your instincts will tell you that, all right, probably this book is how Postgres, became a Swiss Army knife. But once you start using Postgres, once you kind of become a member of that Postgres user community or core Postgres community, you will realize that just use Postgres doesn't imply that Postgres can replace every other database. That's not the case. It's not possible. But it's just a hint from the community, just a good piece of advice, saying that Postgres is a very capable database. Most of the people know Postgres as a relational database. And when you think about relational database, kind of think that an RDBMS is only good for OLTP workloads, transactional workloads, and that's it. And then if I need caching, and then if I need vector search, and then if I need full text search, I need to switch to other databases. But the just use Postgres implies that, come on, before you make that decision, and that can be a good decision to use another database, take a look if Postgres already does this for you, like with these PubSub capabilities. Yeah, Postgres has special extensions. One of them is PGMQ, Postgres Message Queue, which is just an API abstraction layer on top of the Postgres table structure, partitions, and some of their special functions and operators. And but with that extension, yeah, if you just need to simple PubSub system message queue, like or job queue, when some job task is put or message is put, and then consumers read and executors execute the task, then Postgres is good enough for that. And not just Postgres. Pretty much you can build comparable systems using other relational databases such as MySQL or Oracle. But why many folks turn to other specialized solutions or databases such as Redis when they think about PubSub is because those databases made a great job on introducing special APIs. Because we developers, if I want to use a PubSub system, I probably just want to see some APIs that look like I will be, exchanging messages or sending some tasks for the execution. Extensions like PGMQ and Postgres, they introduce that abstraction. And you just start your database, and then you use familiar APIs that will create a queue, and then you will be putting messages in the queue, you will be reading the messages in the queue. But under the hood, everything is stored inside the same relational tables. Everything you also will be internally, it will be using transactions, making sure that you do not read the same message twice, so that everything which is updated consistently, and so on and so forth. This is one of the examples. But at the same time, what I'm warning the readers about in the book is don't be fanatic, because if, let's say, you was successful, right? You use Postgres, and like it's okay to say just use Postgres, because explore Postgres capabilities before you switch to something else specialized. But if, let's say, Postgres just doesn't really work for that streaming use case, when we talk about streaming, something that is usually provided by Kafka, you stream data from a bunch of readers, then you have a bunch of consumers who need to read the same messages, do something more kind of specialized, more advanced architecture, then probably instead of trying to build a bicycle on top of Postgres, use Kafka instead. This is my rule of thumb. So just use Postgres, to summarize here, is just a good piece of advice to you, because if you already know Postgres, if you're learning Postgres, then consider it for other use cases before you use specialized databases. Why? Because the fewer components you have in your architecture, the better. Once you go in production, you need to support not just Postgres, but other specialized system. But if during that POC, during that exploration phase, you see that, all right, now Postgres kind of doesn't work that well for this full text search use case, and I need definitely Elastic, then go for Elastic. But also there will be scenarios, and you'll be surprised to see those scenarios when Postgres can handle your full text search use case exceptionally well, and you don't need to run a standalone Elastic cluster. Basically, this is how I see the book, and this is the main objective, and this is how I usually explain the Just Use Postgres title. Does it make sense to you?
No, I heard it because I listened to you on at least 2 different podcasts today, and I think you've said it many times, basically the same thing, and so I understand what you're trying to say. The title's a little bit kind of cocky and arrogant, but I mean, I think it's fine. It's just you want something to kind of shock you, even though like we already understand. When you read the book, when you listen to your what you want to say, it makes sense. But it's definitely something that like kind of shocks you. It's like, why should I just use Postgres? But it's a bit more than that, right? I remember like, and actually that's something that surprised me a lot when I started learning more about Postgres, is all the function it has. And that's what made me start to realize like, okay, before I reach for another tool, I definitely need to actually take a look to see like, can I actually do something? Can I accomplish the same task without Postgres? Like the PubSub thing, I specifically had like a kind of some of a microservices architecture quite a few years ago.
Mm-hmm.
I had to communicate from one system to another, and there are different programming languages, different platforms. And, you figure like, okay, HTTP is one way to do it. But I think I couldn't do it because they were like in containers and totally like separated for some reason. I'd spent many years. Oh, wait, sorry. I know what it was. I believe it was using Kubernetes. Obviously, I could use services and things like that. But I decided, okay, why don't I just push the message over PubSub and then let it, handle it. I think it was like some kind of AI crunching data thing. So it just made sense just to pump it over Postgres, and it would, take the message and then do what it needs to do and kick it back. It's definitely something that's woken me up.
So was that some sort of a job queue, like not just a message queue, right? Someone would post a task to execute, and then some other component would need to pick it up.
Yeah. So for this one, it was something like a job queue, but it was just only PubSub. It was just like send a message to like crunch some data or something like that. It's been so long, I can't remember. It's been over 5 years and many projects since then. Postgres as a message queue, I thought that was interesting because I never thought about that. But I do use this package called Oben, which is available. It's written in Elixir, but it's available for like Python and Elixir applications, where it basically it's a messaging queue, like it's a job queue. You stick a job in there, it runs it. You can also give it a cron-like interface where it can run a job every X amount of times. It's got it sticks all the jobs right into Postgres in it. And they use a lot of Postgres features. I haven't dug into what the heck they're exactly using. You may have even heard of it. I don't know. It's somewhat popular.
No. Does it run as a Postgres extension? Does it run inside of Postgres, or is it just no? Okay.
It's outside Postgres. It just heavily uses Postgres.
Okay.
I mean, so I got introduced to Postgres because of Rails like a long time ago. And then I switched from Rails over to Elixir, and I've been using that a lot for a lot of applications. They just naturally went straight to Postgres because the guy came from the creator of Elixir came over from Ruby, and and also like for relational databases. I mean, we both really like it compared to others. I remember my first issue I had was like with MySQL, where actually I was saving. I don't know if you know or not, but I'm based in Hong Kong, and before I used to live in mainland China, and something I noticed right away was that MySQL, at least at that time, you can give it data and it would just store it, as opposed to, I believe Postgres actually has a protection so that it doesn't just store like garbage, because we end up storing some bad characters somehow. And so like when I went to read the data, it would just like crash because the data was basically corrupted, but still got saved in MySQL at the time.
Yeah, I don't know about that one, but Postgres as a relational database, whenever you update any record or you insert any record, let's say that when you insert any record, a new record gets created and stored in the database. If you update an existing record, like your bank account, it doesn't overwrite the record in place. Instead, it does a full copy of your existing record and introduces, the required changes. But the previous version of the record, it still exists, and it still exists in the same table. When you, let's say, when you do this, over and all over again, you keep updating the same record or a bunch of records. The previous versions of the records will be existing in the database. It will be consuming some storage space. And how does the database deal with those dead records or dead tuples, like basically garbage? It has garbage collection. So same as Java, same as JavaScript or other programming languages, Postgres and many other databases, they use the garbage collection. Because Postgres creates those versions for the sake of the transactional consistency, for the atomicity. It wants to make his kind of, regardless of all of the modern general purpose capabilities Postgres has, there is one use case that which Postgres has to accomplish, not just good enough, but exceptionally well. And this is transactional workloads. That's why this is how the system is designed. Speaking about PubSub, my story is why this chapter about Postgres as a message queue. So in the book we have, for those who are listening to us, in the book, in the very end of the book, we have the last closing chapter called Postgres as a message queue. Initially, I didn't plan to add it to the book, because I was also skeptical, probably like same as you, Alan. You did not know about this use case, but many people who know about this case, they might be skeptical. And eventually, but why I changed my mind and why the chapter appeared in the structure? When you write a book with Manning, you have several phases, and one of the phases is called MIP. It stands for Manning Early Access Program. And what happens, let's say that you as an author, you crafted the first 4 or 5 chapters. And once the publication teams decides that, okay, those chapters are good enough, they will release your book draft as an early access, version with everyone, and you will be able to read it electronically. So this is exactly what we did with the Just Use Postgres book. Once the first chapters were completed, we released it in this early access program, and I basically shared the news with everyone on social. And I went to Reddit. On Reddit, we have a very vibrant Postgres community, Postgres SQL subreddit, where I just posted, guys, like, look, this is the book I've been working on. This is the current table of contents, and the first chapters are available, and this is what I'm planning to work on next. Just looking forward to your feedback. And I genuinely wanted to hear the people's feedback. And then what happened is there were a couple of folks who posted some feedback saying that, all right, yeah, we like the book, we like, the where it's going, but then it's like, what's happening? There is one, topic which is not covered. It's missing, like Postgres as a message queue. And they would explain why this topic would need to be in the book. And under those, 2 or 3 comments which were in the discussion, I saw, let's say, like dozens and dozens of thumbs up. And after that, I decided, all right, look, probably the guys who are asking to include Postgres as a message queue in the book are very knowledgeable, and they convinced that Postgres can not just tackle this use case, but it can support it exceptionally well. And I changed my mind. I went to the publisher and said, like, Jonathan is my acquisition editor. So I said, like, Jonathan, like, we gotta add this chapter back to the book. We added this chapter, and then that was my last chapter. I studied much more than I did for the other chapters in the book, but I enjoyed it. And after finishing this chapter, now I'm a big believer that, you can use Postgres as a message queue for PubSub system, but also be mindful that it doesn't replace Kafka. It doesn't replace any other specialized streaming technologies. But if you're a Postgres practitioner, if you're already experienced with Postgres, and all you need is just to add some, like as you, Alan, said, some communication between different components of your system, that communication might be possible to implement by using database as a queue. And Postgres is your friend here.
Which always makes me kind of nervous because, no database can be like great at everything. Like I went to a database launch party about, 5 years ago or so. Mm-hmm. I was a bit skeptical because I wasn't quite sure what kind of database this was. Nobody was actually able to answer the question. I'm talking about, like, is this relational? Is this document? Is this, whatever? And I never really got an answer. And I asked the founders, I'm like, what is this database good for? And they replied, everything. No way one database can, like, be great at every type of database kind of thing. Although Postgres does come pretty close. You can store JSON-B documents like a, what do you call that? Like a document.
Yeah, JSON. Yeah, yeah, JSON is a data type. Postgres, yeah, speaking about Postgres, I usually explain Postgres as a general purpose database. And general purpose implies that, yeah, you can use it for various use cases. And the use case can be relational data, like a transactional workload. It can be generative AI applications like the vector search. It can be full text search, etc. But that doesn't mean that Postgres is specialized in those workloads. Let's say, let's take full text search as an example. Postgres has built-in data type and has built-in functions and operators that will help you to take your text, kind of convert the text to a list of lexems, like units of language, and then perform the full text search over the data. The default and Postgres has some of the specialized indexes, built-in specialized indexes for the full text search data type. You can use the GIN index and I think the GIST index as well, if my memory doesn't fail me. However, when you compare this to Elasticsearch, there is a specialized ranking algorithm which native Postgres misses. It's called the BM2 ranking. So this BM2 ranking algorithm is basically what powers Elasticsearch and other specialized full text search systems, and it's quite and Postgres did not support it. And this is why, sometimes people would try to use Postgres for full text search. Sometimes it would work, sometimes it would not, depending on the data which you store. And they would switch to Elastic because Elastic, did it better because of that BM2, BM25 ranking algorithm. And how like this, but then Postgres can always catch up. Right now we have a couple of extensions. One of them is PG text search, and they implemented this BM225 ranking algorithm for Postgres, so you can install it. So this is basically what you have with Postgres. Yeah, it was designed as a relational database, but it was designed as a relational database which can be extended. It's very extensible or extendable. And Michael Stonebreaker, he is like the original creator of Postgres. It was because Postgres was born in Berkeley University, California. It was the project. Postgres basically stands for post ingress. So there is the ingress database. What Michael Stonebreaker noticed, there is a wonderful kind of interview with him where he explains everything. What he noticed is that ingress was very powerful relational database, but eventually the times were changing. New use cases would emerge, new types of applications would need to be built, and those new use cases and applications require different data types, require different index types, etc. And it was hard to catch up with all of those demands by enhancing and building the ingress database engine. And then he envisioned that like the next database engine, which became Postgres, it needs to be not just a relational transactional database, but it also should be easy to extend it if it's necessary. And it can be extended not just by the core database team, but also by the people who want to introduce their own custom data types or custom functions and custom indexes. So some of those capabilities, they eventually get back into the core database engine. JSON is an example. Postgres supports JSON and JSONB data types, and this is part of the core database engine. Yeah, you can store JSON documents. There are also specialized indexes and functions which will let you query them. But it doesn't at the same time, and this is basically shows how that architecture, the concept which Michael Stormbreaker put in place, works out today. This is why Postgres is so ubiquitous these days. This is why it's so widespread, because Postgres core database engine is very, I would say, conservative. They do it's there is a lot of innovation in the core database engine, but they do not do this rapidly. For instance, if you want to improve something on the replication side, it can take a couple of years, because they just we release Postgres Postgres version every year, major version. And if, let's say, your capability doesn't make into this release because like some of the folks didn't manage to review it, didn't have time to review it, or because there are some of the gaps which needs to be addressed, all right, it will get into the train the next year. So this is how the community builds Postgres. But if you want to introduce something much more rapidly, you have extensions. Take a look at the pgvector. Pgvector is an extension for, I would say, for the generative AI applications. It allows you to run the vector search, the vector similarity search over your embeddings, and it also introduces a special data type called vector. It was created actually before it was created before ChatGPT, before everything became so popular and ubiquitous. It was used for some of the search over the vectors, and those vectors were not embeddings which are generated by LLMs. But once ChatGPT was released, once people started building specialized vector databases, folks who use Postgres, they say like, look, Postgres already has this, and it's not in the core database engine, but we have pgvector extension, and the pgvector extension maintainers that continued improving this extension, so it has some of their contemporary index types. It's being improved, it's being developed. So this is an example. But if, let's say, you have because if you have Postgres right now, and let's say Postgres is released only like once a year, if Postgres did not have that extensibility, then the development community would need to wait while all of those, let's say, specialized indexes and vector types would be added into the core database engine, which could have taken years, especially if you consider how Postgres is being developed. But you have extensions, and everything in Postgres can be extended, really quick. You don't need to wait for anything added to the core database engine. Just go ahead and develop it and release it as an extension. So this basically explains why Postgres is so popular and why we have these people like me saying just use Postgres. When I'm saying just use Postgres, my hint is just take a look if Postgres, will serve you well for your use case. If not, then just go and use something else.
Yeah, you touched on a lot of really interesting topics in there. One that there's another one I really want to bring up, but I forgot it now. But there's actually another one that's even more important for people who are kind of new to Postgres or want to give it a try and they want to store JSON data. Maybe you should have had a chapter in the book called Just Use JSON B, because I remember correctly, JSON is like a very quick iteration of holding JSON data. What I remember is like people kind of described it as we had to get some JSON in the system. Now that we thought about it some more, JSON B is the better one. Just try not to use JSON anymore. That's what I kind of have gotten the gist of. Is that still the case? Because that's what I hear.
We do discuss JSON versus JSON-B in the book, but we do have JSON-B in Postgres, and this data type should be used by default. But it doesn't mean that we do not need JSON, the JSON type. So what's the difference? The JSON-B, when let's say you have your record, you insert your record, and one of the columns is of the JSON-B type. It stores you some document. Let's say it can be some metadata about the applications on your screen, placement of the applications on the screen. If this column is of the JSON-B type, then Postgres will kind of read it, and it will optimize it for the storage. Why it does it? Because if then you're going to read the records and filter the records by the content of the JSON column. Let's say that in that JSON column you have the field called display. Under the display you have a number, right? And there can be, let's say, 1, 2, 3 displays. And then let's say you run the query like select everything from this table where display number equals to 3. And when Postgres uses JSON-B, all of those records are already kind of were analyzed when you insert the record, and then it will be much faster for Postgres to retrieve this data from the database. It doesn't need to, read the entire JSON document and deserialize it. It will be able to get to this data quickly, especially if you use specialized indexes, and those indexes can index the column of particular fields like display or the entire path, such as display number. However, the JSON data type, what happens with the JSON-B, whenever you insert your JSON-B column and you then want to read it back as is, Postgres doesn't guarantee you that you will get it in the same shape and form. For instance, if in that JSON document you had some, a couple of duplicate fields, like at the top level, let's say you had a field called a field called display name, and then somewhere down below you had the same name, the same field with the same name, display name, then Postgres can remove this because it will tell, all right, like, why do you have this duplicate? Or it can kind of rearrange some of the fields in your JSON structure, thinking that it's okay to do for the sake of performance. But for some of the applications, it can lead to different errors. Some of the applications might need to have a display name column in the top root level, twice. I don't know why, but there might be some of such use cases. Or you might need to have this kind of a specific arrangements of the columns in your JSON structure. And if this is your case, then you need to use JSON, the JSON type. I use JSON type for the scenario when, let's say, I'm not planning to query this JSON structure in Postgres. Let's say that I have some metadata object and I just put this metadata object in Postgres. I'm not planning to filter. I'm not planning to query this metadata object. All I need to do is for Postgres to take this object, store it for me, and then whenever my application needs it, I will just read it back. So in this case, I use just the JSON data type. Also, I use the JSON data type when I'm dealing with the write-intensive workload. Let's say that, again, I have this prerequisite. I am not going to read the contents of this JSON object on the Postgres side, and I'm inserting a lot of the records with the JSON structure. When you insert, let's say, those JSON documents in the JSON type, then Postgres doesn't do any pre-processing. It doesn't try to analyze your JSON structure. It doesn't try to do anything else. It just takes your data and stores it in the storage engine. So this is the use case for the JSON. And then but for the most of the use cases, when you want to query the JSON structure on the Postgres side and you want to index it, then I would use JSONB. So this would be my advice. So both data types here exist for reasons, and as everything in the software engineering, there is some trade-off. That's why folks who will be reading the book or who will be learning and using Postgres by referring to different resources. Yeah, don't dump the JSON type just because everyone says that JSONB is better. JSONB is better for particular scenarios. Yeah, there might be much more scenarios where JSONB is suited for, but there is always, there are always scenarios where JSON will suit you better. Just study what the database, offers.
Yeah, it's quite interesting because I remember hearing that nearly everywhere. It's like, just ignore JSON. It was a quick implementation. And then now that we have JSONB, forget about JSON. So it's good to hear that. I didn't actually know that there's actually any good use, because I'm always thinking, like this morning I was listening to your podcast and I was like, why we still have this one? Like there must be a reason. I mean, maybe backwards compatible, like, Microsoft like never get rid of some old API because, something may break from many, many years ago, right? That everybody's kind of relying on. I think Linux said it himself. It's like once a bug becomes something that people rely on, it's now become a feature, so you can't really remove it. That's what I thought about the JSON type. So it's good to hear. Like now, actually, I made, like you said, you gave some really significant, like actually useful use cases for JSON. So it's good to hear about that. The other thing I thought was really interesting, because I was reading like I think you had some tips in the back of the book, which I was just kind of going through. One that I think is very useful and it reminded me of a website. I'm sure you've heard it before. It's Just Use the Index or something like that. Do you know what I'm talking about? There's a website where this guy has all these kind of
just use the index look, right? The look.
Yeah, the Star Wars reference. Yeah. So like it reminded me of that. Yeah, because I recently had a performance issue I had to help somebody deal with. And I was like, wait a minute. And then you also have talk about using explain, which is so helpful. Like I just use explain just to like make sure. And also I showed him, you see this one is a sequential scan. That means one by one for all these thousands of records we have, it's checking one by one. And then I added in the database and I reran I added in the index, reran the explain. It's like now you see how much faster it is, and you see it's no longer doing sequential. It's going straight to the index, finding everything very quickly. The client was very happy because this is like a long time problem where it's taken like 30 seconds just to paginate like 10 records.
In the book, I have that last appendix where I list my top 5 optimization tips for application developers. The explain statement in Postgres is one of them. So basically, as you explained, what explain does, you have this query like select star from some table where something is something, and if you want to see how Postgres executes or planning to execute this query, you just add the explain statement with probably some parameters before this select, and after that you will see. For some of the folks in the beginning, it will look like the magic because you will say, all right, this is what the database is planning to do or have already done. For some of the folks, the output can be discouraging because there is some learning curve, not significant one, but you need to learn how to read those explain output. But why it's necessary is similar to your use case. We do not need to, all of those cloud providers, even in the time before the cloud, when we had the DBA teams, which were running databases in our on-prem infrastructures. They wanted just developers to focus just on applications, and that's why for most of the developers, their databases remained a black box. It's like something is deployed in the cloud, or someone in my company provisioned this database for me. This is a connection string, and I started, doing something. And then what happened? Let's say you have some high latency, you have performance issues. Then you would go and talk to your DBA, and the DBA would point out like, no, like this is guys, what you did wrong. And then, or you would just get some ticket from a cloud provider. You would create a ticket for a cloud provider, and then the cloud provider will tell you the same, that guys, you have some issues with some queries. And but the thing is, you can minimize the number of such tickets to the cloud provider, or minimize the number of conversations with your DBAs if you have a dedicated database team in your company. If you at least strive to understand how the database, executes your queries, and how it will help you to design much better queries and optimize them. And it explains this is the case. When you create your table, probably in the beginning you have just a couple of thousand records, and everything performs fine. But then let's say you have some of those queries, and those queries filter data by column A, B, and C, etc. And then suddenly, for some reason, a half a year later after the product launch, your queries, are running slow. Why? And you're just scratching your head. You don't understand why, because everything was fine, a week ago. But probably because the database right now, because those queries might not have been ever optimized. It was, as in your case, Alan, they were doing the full table scan, checking every record one by one, trying to complete your query and find all the records which match the condition. But then let's say once Postgres crosses some, threshold, you have, let's say, 1 million record or more records, this full sequential scan will become eventually expensive, and it will hit you badly, because Postgres might not longer have enough CPU cycles, enough memory, or something else to execute it efficiently. And only then you start realizing about indexes. And indexes is obviously one of the most widespread optimization techniques. But if we start creating, let's say, indexes for all of the queries, just let's say, okay, I have this query, I need this index. I have that query, I need another index. When you have many indexes, it also can hit you badly, because Postgres, every index consumes storage and memory space. It doesn't come for free. Every index needs to be maintained, meaning that whenever you update your records, if any of those fields are indexed by some index structure, those index structures needs to be updated. So let's say you're updating one record in your database, and then that record is indexed by 5 indexes. Postgres also needs to update 5 indexes transactionally before this update is completed. And also during the execution of the read request, like select, if you have, let's say, 5 indexes and also the full table scan, and Postgres can use any of those 5 indexes for the execution of your query, Postgres will spend more time on the planning phase, trying to realize, okay, which index should I use? But it's always great to see that when people start using the explain statement, because once you start using the explain statement, you will understand, the difference between like the power of indexes. And then when you start using the indexes, also don't, overuse them. There is the problem called over-indexing, when you created too many indexes, and now you have problems, let's say, during the planning phase. Now you have problems with writes, because you have write amplification. Indexes needs to be updated as well. Then you have storage space problems, and then people realize, okay, there are some other ways how you can optimize, Postgres, and basically they start diving deeper into the database. But generally, all like explain, my belief is that every backend engineer, or everyone who is working with a database directly, and this database is Postgres, they need to know how to see and analyze execution plans of Postgres.
Highly agree. It's something that everybody kind of like needs to pick up at some point, because it's very, very useful. So we are starting to run at the end of the time. Last chance to kind of leave some parting words before we head off.
I would probably just repeat myself. The goal of this book, the book is about Postgres, but there is a wonderful afterword in the book, which was authored by Vlad Mikhalsov. What he pointed out too is the books like this one helps us to build simpler systems, simpler applications. And what the simplicity means here? The simplicity means that use as fewer components as possible. Just don't use Redis just because you think you need a cache in your use case. Probably no. Probably you don't need Redis right now for this use case. You just need to give more RAM to your database. That's it, because database also caches everything in memory, like Postgres. If you're same as for the vector search or for the full text search, probably you don't need to introduce a specialized vector database or full text search database if Postgres already fully handles your specific use case. This make it simple approach will make your life simpler, because once you put anything in production, you need to monitor this, you need to maintain this, you need to upgrade this, right? You need to be on those outage calls, and it's going to be good if you manage to design a system which has a fewer components. Then you should have fewer problems. And the Just Use Postgres is one, like the book shows you how you can try to achieve this with Postgres. But if you use another database, if you build in some other systems, then you can apply the same concept for everything else. Just don't use any other technologies just for the sake of using technologies, or just because everyone does this. Use only those components which are really necessary, because you will have a simpler architecture. Strive to achieve the simplicity, not the complexity.
Definitely well said. Well, again, Denis, thanks for coming on. We do have a discount code for this book. Definitely pick it up. Buy it straight from Manning, so that way more goes into the pocket of Denis and less into Jeff Bezos. We don't want to keep propping up his, I don't know what he's doing these days. Is he still going to space? I don't even know. I'm not sure what he's up to.
Yeah, I
these
think
days.
so. I think that he's enjoyed the life. Yeah, he has some hobby. He has some hobby in the space, right?
Space, yeah.
In the space.
Yeah,
I don't know.
I mean, we're all of us kind of like technical people. We all have some kind of interesting hobby after we kind of like retire. Like I know one guy, he's into astronomy. Another quite a few developers like to be flyers. I'm not too sure why we want to fly. But in any case, again, it's great to have you on, and maybe you'll come back with Just Use Postgres version 2, right? Or you said, I think another podcast, you're not interested to write another one anytime soon,
Not
at least.
now. Not now. No, just I'm done with writing the books. It's kind of a mixed feeling. It's a joyful process. It's like with everything. Everyone had this moment when you're working on something significant, right? It can be something work related, can be some personal project, probably some physical. You're training, preparing for something, and then let's say you're running some long distance, such as a half a marathon or marathon, and it's a painful distance. And eventually, when you cross the finish line, you just feel empty. It's like, okay, it's done. And you kind of sometimes you don't want to repeat this again. But then what you remember the process, the time that you took to prepare for that. And the same is with the book. The most joyful part was the process, but it definitely requires a lot of your personal time. Once the book is published, come on, it's done. And then you start and think like, all right, do you want to start doing this again? Because it took me like, I think a year and a half just to write this book from scratch and to get it published.
I remember you said like 18 months. You're like, it was quick, 18 months. I remember myself, 18 months is not quick. At least for me, it's not quick. It's a long endeavor. It is like a marathon, like you mentioned.
Yeah, it was like around 15 months, like 13. Yeah, I started writing it in late July or early August 2024. And it was published, a printed copy was published in November 2025. Yeah, so basically it's like 13, 15 for like 14 months, if just to be precise.
We're end of February, and you're still kind of promoting it, which is quite interesting.
It's seems like I mean, I slowed down. Okay. I slowed down, but right now the book pretty much lives by itself. But it's always grateful to hear feedback from those who read it and find it useful. At least, this was my contribution to the Postgres community, because Postgres is kind of my default database, which means that if I start a new project, I will explore Postgres first. If Postgres doesn't fit, then I will use another database. And I spent a lot of the time working with Postgres. That's why I decided to write how can I contribute back. And the reason why I just wanted to write this particular book, because even you kind of noted that, okay, you didn't know that Postgres can be used for this or that use case. And I had the same knowledge gap probably like 3 or 4 years ago. But then I worked for another company called Yugabyte. They built distributed version of Postgres, and I was paid to study Postgres. And when I was studying Postgres, I read, oh, come on, really Postgres can do that? And I was talking to friends of mine, to colleagues, to different folks at different events. And I heard the same kind of feedback. Oh, I didn't know that Postgres can do that. Seriously, Postgres is kind of... And I said, all right, I got to do something. And I decided just to write this book. This is my contribution to the Postgres community. Hopefully it will help more users to jump on the database and use it properly.
Well, thank you for your contribution. And I just want to say one more time, yeah, we'll definitely have a discount code for the book. Yeah, thanks again for the contribution. And, hopefully you can keep contributing just a little bit more. Maybe not another book, but maybe in other ways.
That's true. Thanks a lot, Alan, for your time, and thanks everyone for listening to us. Yeah, if you have any questions, you can find me on social, LinkedIn or Twitter. You can add my Twitter and LinkedIn handlers to the description of the podcast.
Yeah, I'll definitely add it over there.